All right, we're working on linear program example number 5. Okay, so here is the question that we're given. So we're trying to ship peaches from the country to the factory where we can put them in a can by a man, and that's what we're going to eat all day. All right, so we set up our linear program, if you recall. It looks something like this. All right, you should have that in your notes. But now we want to be able to set this up into Excel. All right, so here is linear program example 5. We have this information already given us, which is what we get from the problem, such that we have 21 miles from Mount Dora to Ocala, our distance here. Mount Dora has 275,000 peaches, Eustis 400,000, and Claremont 300,000. This bottom number describes the capacity constraint of each factory in Ocala, Orlando, and Leesburg. All right, we want to set this up. So first we want to be able to define our variables. So I'm just going to copy and paste this down here. All right, and I'm going to delete everything. So I highlight it, I push the delete button, and now it's empty. So these are my variables right here. Okay, such that X1 is going from Mount Dora to Ocala. That's this cell here. X2 is Mount Dora to Orlando. That's that cell. There's 9 cells and we have 9 variables. So that's great. Right, so those are my X's. My objective is to minimize total bushel miles. Okay, now that's not to be confused with bush miles. That's what you do in Australia. These are bushel miles, which you do when you have peaches. Well, the bushel miles is equal to, based on our linear program, is 21 times x1, 50 times x2, 40 times x3, 35 x4, and so on and so forth. So this is equal to the sum product. Now I could do that by hand, or I could just highlight this box of 9 variables and then highlight this box of 9 variables. And because they're corresponding, it's going to take the top left box and multiply it by the top left box, and then add the top middle times top middle, and so on and so forth. I click enter, and there we have our total bushel miles. Now when you think about our other constraints, okay, the first constraints we had was a set of 3 constraints, is that x1 plus x2 plus x3 is equal to 275,000. Well, this right here can be equal to the sum of x1 plus x2 plus x3. And there's our left-hand side variable for that. Oops. Let's try that again. I may have clicked the wrong button. Sum of these 3. There. Okay, I'm going to drag this down. Now we go from there. Now the right-hand side is right up here. Here's the right-hand side, 275, 400, 300. Now over here, our capacity is equal to the sum of, we have x1 plus x4 plus x7, which is just the sum of these 3 columns, or these 3 cells. I copy paste that over, and there we go. Now I have it all set up in Excel. All I need to go is to do solver correctly. So I go data, solver. My objective is to take my total bushel miles, to minimize it by changing all 9 x's. I'm going to add a constraint such that the amount I have coming from the orchards is equal to the amount I have in the orchards. The other is that the amount I'm sending to each factory is less than or equal to the capacity of each factory. I click OK. I'm going to go to Simplex LG. I'm going to make unconstrained variables non-negative. I click Solve, and something bad happened. Okay, so this is going to be an example of, can we figure out what we did wrong? Okay, let's find out. Okay, so this is C12 to E120. That's a little bigger than I hoped. Okay, so that's going from E all the way down. So let's just change this is equal to sum of these 3. That might be a little nicer. Drag that down. Okay, now let's try that again. So sometimes just checking your equations. Now that looks a whole lot nicer. Okay, so this is going to be the correct answer we have here. So we're going to take 200,000 of our 275 that are in Mount Dora, ship them to Ocala, none to Orlando, and 75,000 to Leesburg. Now from Eustis, we're sending most of them to Orlando and the other part to Leesburg. Claremont sends all of them to Orlando. And that's our problem, our answer. Awesome. So we've answered that, but now let's go ahead and check out the sensitivity report to see what we can learn from that. estimate the sensitivity report. Okay, and here's what I have. Okay, so we have different constraints, focusing down here on our shadow prices, of capacity of Orlando, Ocala, and Leesburg. So right now, Ocala has a capacity of 200,000. So what we're saying here is if I can take that capacity and increase it by 1 to go to 200,001, my bushel miles will decrease by 27. Right? That's not bad. So I want to increase the capacity at Ocala to decrease my cost function. Now, if I increase the capacity at Orlando, it actually has no effect on my cost function. And that's because Orlando is not operating at capacity. We're sending 550,000 peaches to Orlando, and they have room for 600,000. So we can increase 600,000, but we still wouldn't send them more peaches. Now, if we look one more time, if we were to increase the capacity constraint at Leesburg, which is currently at 225,000, that'll increase our cost, or rather decrease our cost by $8. Right? Now, in terms of looking at our allowable increase, what this tells us is, so we're at 200,000, as long as we're increasing it by less than 75,000, the shadow price will be constant at $27. All right. Once we increase it above 75,000, now the shadow price is no longer constant. Well, what about these? Well, this tells us that if I have, right now I have 275,000 peaches in Mount Dora. If I were to grow more peaches in Mount Dora, if I were to increase the number of peaches in Mount Dora by 100, what that tells me then is my cost would increase by 4,800 because I'd have more bushels of peaches to ship to other places. All right, so it's 48 there, 30 and 20. So if I had to increase the supply at any given one grove, what grove would I choose? Well, I should choose Claremont because that is going to increase in the capacity at Claremont. It's going to be the least miles required to ship it to a different factory. And that's how we interpret the shadow prices.